Okay, so today I want to give a quick discussion of the binomial distribution. Remember, a distribution is the function which takes a set from our probability space and returns the probability. So since we're going to be thinking about the distribution that you get, for instance, by flipping a coin n times, we're going to have the distribution on the number of heads we get, the number of successes. Or for instance, if we have boys and girls, if we want to know the number of boys in n births, then our distribution would be on the number of boys we get, or alternatively the number of girls. So we're thinking about a distribution on the set 0 up to n, the integers. And we want to think about what happens if we consider this distribution with some probability p of success. So, and this will usually be written binomial np, or sometimes binomial np equivalent. So we want to think about, so we have p, which is the probability of success, and q equal to 1 minus p, which is the probability of failure. Okay. And we want to ask, what's the probability of k successes in n tries? Alright? Okay, so there's a very simple way of kind of thinking about this, so I'm going to draw a picture which is very useful in this. So what I'm going to do is let's start off by saying we have n equals 0 tries. And now I'm going to say, what's the probability of k equals 0 successes? So always I'm thinking about k success in n tries. Well, the probability of getting 0 successes and 0 tries, and it's a little bit of a degenerate case, but we'll think of that as 1. The probability of getting 0 successes is 1. Now it gets more interesting if I say, let's go to n equals 1. Well, now I have two options. I can have 0 successes or 1 success. Now the probability of having 0 successes means that I have a failure the first time, and that happens with probability q. And then I'm going to write the probability of this event happening here, so that's q. Now the probability of having 1 success, that happens with probability p, and so I'm going to write probability p here. Now let's go a little bit farther. N equals 2. Now again, I of course have 0, 1, and now I have k equals 2, and let's just go ahead and write k equals 3 for the next one. So now I have 3 circles, 3 possibilities I could end up with. And when n equals 3, I'll have 4 circles. Now, if I continue to have no successes, I have to get another failure, so that's q. So now, I've come down here and I get to this one, and that's q times q, so this is q squared, because these events are independent. Now, there are 2 different ways I could end up with 1 success. I could have a success and then a failure, or I could have a failure and then a success. Now each of these paths are independent, they're disjoint, and they have probability p times q, but there are 2 of them, so I end up with 2pq here. And now the only way I can get 2 successes in 2 tries is to have all successes, and now this probability is p squared, but there's only 1 path, so there's a 1 in front. Now just to kind of see if you're getting the idea, we'll go down one more. This one is q again, all failures, and that's q cubed. Now, there are 2 different routes to get here, so that is, what is it? This happens to probability p, and this happens to probability q, so this one is pq times p, and this is, this is the failure, excuse me, I got that wrong, do you see I got it wrong? And this is p, so again, all the factors are p times q squared, right? Because this q squared times p is p times q squared, and this is pq times q, which is p times q squared. And now the number of ways to end up here, if you count them all up, is exactly 3. there's this one, there's this one, there's this one. Alternatively, since this one already counted up the number of ways to get here, and this one counted up the number of ways to get here, we just add the coefficients in front, which gives us a 3. This is sometimes referred to as Pascal's triangle. So now, this one will be, we multiply the coefficients and we get P, is that right? Yes. This one, we're going to have Q's from here, P's from here, and Q's from here. And so this will be P squared Q. And again, there are 2 ways to get to here, so we get 2, and then there's 1 way to here, so the total is 3. And lastly, we have just another success, which happens to be probability P, and so this one is P cubed, but there's only 1 option. Okay, we can keep going, we can keep going. Now it's also useful to note that we can think of this as just P plus Q, the expansion of P plus Q. Write that out, maybe a little Q to the first. And this one, that's just equal to P plus Q, which you notice is the terms I have here. And now if I think about P plus Q squared, if you square that out, you get Q squared plus 2PQ plus Q squared, which is exactly the terms I have here with exactly those coefficients. And lastly, I'm going to write down here since I'm running out of room, but if I write P plus Q cubed, then I get Q squared plus 3P Q squared plus 3P squared cubed plus Q plus P cubed, which is exactly the terms I have here. Alright? And of course, since P plus Q, remember P Q equals P1 minus P, so which implies that P plus Q equals 1. Of course, this is 1, so 1 to the 1 is 1, and 1 squared is 1. So all these terms sum to 1, which makes sense probabilistically because we asked, well, if I sum up the chance of getting in 3 trials 0 success, 1 success, 2 success, and 3 success, I should get 1, since those are the only possible things that could happen. Right? Alright, let's go a little farther with this.